Welcome back, tech enthusiasts. Today we're diving into the fascinating history of the first programming language. Now, you might be thinking, programming languages, those things that let us build apps and games and power the entire digital world, how old can they really be? Well, get ready to have your mind blown, because we're going way back before smartphones, before the internet, even before computers as we know them existed. That's right, we're talking about a time when the idea of a machine thinking or calculating was revolutionary. Let's get started. Let's set the stage here. It's the 19th century, the 1800s. The Industrial Revolution is in full swing. Machines are changing the world, but they're mostly mechanical. The idea of a machine that could think or calculate beyond simple arithmetic, mind-blowing. This is the world in which our story takes place. It was during this time that the very concept of a programmable machine began to emerge. Think about that. The idea of programming was born before the machines themselves even existed. It's like imagining a smartphone app before you even have a phone. Enter Ada Lovelace, a mathematician, writer, and all-around visionary. Born into a world where women were often discouraged from pursuing science and mathematics, Ada Lovelace defied the odds. Her father was the famous poet Lord Byron, but her mother, also a math whiz, made sure Ada got a top-notch education in mathematics and logic. This foundation would prove crucial to her groundbreaking work. Ada Lovelace was a true pioneer, combining her mathematical prowess with an incredible imagination. She saw beyond the limitations of her time, envisioning a future where machines could do more than just crunch numbers. They could create, they could process information, they could, dare I say, think. Now, Ada Lovelace didn't just dabble in mathematics and daydream about the future of computing. She dove headfirst into the world of what we would now call computer science. She collaborated with Charles Babbage, the inventor of the analytical engine, a machine considered by many to be the first mechanical general-purpose computer. While Babbage was focused on the hardware, the gears and levers and mechanics of the analytical engine, Lovelace saw its true potential. She realized that the machine could be much more than a glorified calculator. It could be programmed to process information and solve complex problems using algorithms. This insight, my friends, is why Ada Lovelace is often considered the world's first computer programmer. Chapter 4. The Analytical Engine, a Victorian Supercomputer. Imagine trying to explain a computer to someone living in the 1800s. It would seem like magic. The analytical engine was a bit like that. A machine so ahead of its time that it's hard to even grasp its complexity. This was a machine designed to calculate, store data, and be programmed using punched cards. Kind of like an early, super complex version of those old punch cards we used to use. The analytical engine, sadly, was never actually built during Babbage's or Lovelace's lifetime. Funding issues plagued the project, and the technology of the time just wasn't advanced enough to realize their vision. But that doesn't make the analytical engine, or Lovelace's work on it, any less significant. Chapter 5, the first algorithm, Lovelace's legacy. Now here's where things get really interesting. In her notes on the analytical engine, Ada Lovelace included something truly groundbreaking. An algorithm for calculating a sequence of numbers known as Bernoulli numbers. This wasn't just some mathematical equation, this was a set of instructions, a step-by-step process that the analytical engine could theoretically execute. This, ladies and gentlemen, is considered to be the first ever computer program, a set of instructions designed for a machine that could process it. It's like the first recipe for a computer, the first code ever written. And it was written by Ada Lovelace, almost a century before the first electronic computers were even built. Chapter 6, Lost and Found, Lovelace's work rediscovered. Sadly, Ada Lovelace's contributions to computer science were largely forgotten after her death in 1852. Her work on the analytical engine and her groundbreaking algorithm remained buried in notes and archives for decades. The world had yet to catch up to her vision. It wasn't until the mid-20th century, as the field of computer science began to blossom, that Lovelace's work was rediscovered. Her notes, once overlooked, were suddenly recognized for the treasures they were. The world finally began to understand the significance of her contributions to the birth of programming. Chapter 7. Fast forward to 1980, the US Department of Defense, recognizing the need for a powerful and reliable programming language for their systems, decided to honor Ada Lovelace in the most fitting way possible. They named their new programming language Ada in her honor. The ADA programming language, still in use today, is a testament to Lovelace's legacy. It's used in everything from air traffic control systems to medical devices, proving that her vision of a world powered by programmable machines was not just a dream, but a glimpse into the future. Celebrating Women in STEM Ada Lovelace Day. Ada Lovelace's story is not just about the history of technology, it's also a story about breaking barriers and defying expectations. In a time when women in science and technology were rare, she made groundbreaking contributions that shaped the future. To celebrate her legacy and inspire future generations, Ada Lovelace Day is celebrated every year. It's a day to recognize the achievements of women in STEM fields, to encourage girls to pursue careers in tech, and to remember the woman who dared to imagine the future of computing. The enduring legacy of Ada Lovelace. So there you have it. The story of the first programming language and the extraordinary woman who wrote it. Ada Lovelace's work laid the groundwork for everything we do with computers today. From the apps on our smartphones to the software that powers our cars, it all traces back to the fundamental concepts of programming that she helped to establish. Ada Lovelace's legacy is a reminder that innovation can come from unexpected places, and that the power to shape the future belongs to those who dare to dream big. What do you think? It's mind-blowing to think about how far we've come since Ada Lovelace wrote that first algorithm. The tech landscape is constantly evolving, but her story reminds us that even the most complex technologies have their roots in simple, elegant ideas. What do you guys think? Does Ada Lovelace's story change how you think about the history of technology? Let me know in the comments below. And hey, while you're there, don't forget to subscribe for more deep dives into the tech world. The very first programming language? Thanks for watching. If you enjoyed learning about Ada Lovelace and the first programming language, don't forget to like, subscribe, and hit the bell icon for more tech history. Ada Lovelace's story is a powerful reminder that innovation often comes from unexpected places, and that even in the face of limitations, human ingenuity can pave the way for extraordinary advancements. See you next time.